Okay, so to kind of go back over the last problem that we did last time, we were looking for the area under the normal curve, which is to say the probability, and in this case it was a standard normal curve because it says the probability that Z is between 0 and 1.24. So 0 is the middle of the standard normal curve, that's the mean of the standard normal curve. And 1.24 is the upper boundary, 0 will be the lower boundary for this. So the command always says that you use normal CDF, which is the second option up here. Once you go to the second bars, which is the distributions menu, and you enter the values for the low and the high. In this case, that's 0, then a comma, 1.24, then another comma, and then the value of the mean, which is 0, and a comma, and the value of the standard deviation, which is 1, and close the parentheses. So remember that anytime you use normal CDF, because we're going to use it a lot, anytime you use normal CDF, you are always going to enter the lower boundary or the smallest number, or where you're starting from, the upper boundary or the highest number, which is where you want to stop calculating probability, and then you're always going to enter the mean, and you're always going to enter the standard deviation. If it's a standard normal, the mean and standard deviation will be 0 and 1. If it is not a standard normal, then you will have a mean and standard deviation given to you in the problem to use in place of that. So when we complete the calculation for this one, we see that it's 0.39251, and if you round that off to 4 decimal places, since the 1 is less than 5, then you just drop the remainder of the decimal, and that turns out to be 0.3925. So we're going to proceed and go to the next example, and we're going to do all of these exactly the same way. So here we have the probability that Z is between negative 2.34 and positive 1.57. And we know that our curve for Z always has a mean of 0, and since the standard deviation is 1, then the next tick mark up is 1, then 2, then 3, and then the next tick mark down from the center is negative 1, negative 2, and negative 3, and those are standard deviation units, just like inches and feet and yards and things like that are units. These are standard deviation units. It's just a unit of measurement. So we go back to our boundaries. And we're going to start with the low. And it says the low is negative 2.34. And we know that negative 2.34 is somewhere between negative 2 and negative 3. And it's closer to negative 2 than it is to negative 3. So we kind of arbitrarily draw a line at about where we think that negative 2.34 is. And then we examine the upper boundary and we see that it's 1.57 on the positive side, so that's past 0. So 1.57 is between 1 and 2, and it's a little more than halfway between 1 and 2, not much. And then we want the area between those two. So the area that we're looking for is this area. And we see that that's actually a pretty large area. So if we were to get an answer like 0.05 or 0.07 or even 0.5, we would probably be a little suspicious of that because this area is almost all of the area under the curve. So it really should be a lot closer to 1 than it would be to even 0.5. So we're going to use our command once again. It's normal CDF. And the low is negative 2.34. The high is 1.57. The mean is 0. And the standard deviation is 1. So we're going to enter that into our calculator and see what we come up with. And we come up with an answer that is what we would have reasonably expected, because 0.93215 is closer to 1. So this area, which is approximately 0.9321, and the next number is 5, we're going to round that up to 0.9322 and drop the 5. And that's this area in the yellow. So remember, the answer we're getting here is a probability, which is represented by the area under the curve. So for our next example, we actually don't even need to use the calculator for this example. We really don't. Because if it says that the probability that z is from -3 to 3, the empirical rule tells us that 99.7% of all the values are between the mean minus 3 standard deviations, which would be the mean being here at 0, -1, -2, -3, and the mean plus 3 standard deviations, which would be 0, 1, 2, 3, so we actually don't even really need to use normal CDF to do this problem. We can actually answer the question based on the empirical rule. And that's a good thing to know when it comes time to actually taking a multiple choice test, which is what your final exam is going to be. Because if the multiple choice test were to ask you this question, and then it gave you answers like 0.5927, 0.98999, 0.95, and then 0.997, or even if it says 0.9970, then you should be able to pick out the correct answer because you know the empirical rule and not have to spend time calculating for that problem. Now, if you do calculate this problem, what's going to happen is the calculator is going to verify what you know. So if we actually calculate this using the formula, that the calculator has built in. That's going to be normal CDF. The low is -3. The high is +3. The mean is 0. The standard deviation is 1. And again, that's because this is a Z curve, a standard normal curve. And it comes back and tells us that it's 0.9973. Okay? Now, if you remember, the empirical rule only went to 3 decimals. Your calculator is going to as many decimals as you want it to, so if you round that answer off, then the answer that your calculator gives you, 0.9973000, if you round that off appropriately to 4 decimal places, you will get 0.9973. But that's still going to match the answer that's 0.997. Okay? Now, on a multiple choice question, we would not make you choose between this and this. It would be more likely that multiple choice question would ask you which of the following 4 answers is correct. What is the probability that Z is between -3 and 3? And then one of the answers might be 0.95, and another answer might be 0.05, which you should clearly know that's wrong. There's always at least one throwaway answer in a multiple choice test situation. And then maybe like 0.4973, and then 0.9973. And you should know, because of the empirical rule, that 0.9973 is pretty close to 99.7%. Okay? So don't forget about your empirical rule. It's always useful. So for our last one, I'm going to fold the paper a little bit so I can move it up some. For our last one, we have the probability that Z is greater than 2.39. And again, that's Z, so it's -3, -2, -1, 0, 1, 2, 3. 2.39 is between 2 and 3. And since it says greater than, that's going to be the area to the right. So our ending number is going to be positive infinity. And remember, what we use for positive infinity is 1 times 10 to the 99th power. So in this case, our 2.39, because it says greater than, 2.39 is going to be the lower boundary. And our upper boundary is going to be positive infinity. So when we put in our command, the area that we're going to find is a very, very small area. Just that very little bit right there. Which means the answer that we're going to get should be less than 5%. In fact, it should be quite a bit less than 5%. It should be very small. So our lower boundary is the 2.39. The upper boundary is positive infinity, which we're going to enter 1E99. The mean is 0. The standard deviation is 1. And I keep marking that to make sure that you get that associated in your mind. It's important that you understand that. So then we'll get the calculator. The second bar's choice number 2, go from positive 2.39 to 1 second comma 99. Second comma gives you your E, and then 0 and 1. And we see that we do get an answer that seems reasonable because it's 0.00842. Which we will round off to 0.0084. And just for reference, remember then that's actually, if you change that to a percent, that's 0.84%. It's not even 1 whole percent. It's less than 1%. Okay? And that explains why that area right there is so tiny. It's very, very small. Now, before I go any further, does anybody have any questions about this? Yes?
So if the arrow goes the other way, then it's going to be below?
If the arrow points to the right, the number that you have is the lower end. It's the starting point. If the arrow points to the left, then that number is the beginning point.
What if there's 2 numbers?
Then it's always between, because your Z, when you have 2 numbers, remember, it's always a low and a high. The arrow's always going to point left, so it's going to be the area between those 2 numbers. Okay? Just remember that if it's 2 numbers, you're looking for the area in the middle. Okay?
Okay, so that's just kind of like my question. So like if you have 2 numbers and the Z's in between, so you put in the numbers like lowest and the highest.
Yeah, the smaller and the larger.
And then 0 and 1.
And then 0 and 1, because that's the mean and standard deviation. And remember that when you have, if you look at it visually, you see 13, or let's keep it in terms of the Z-scores, negative 2.5 is less than Z is less than 1. Well, negative 2.5 is the lower number, and 1 is the higher number. And if you look at and see where, where is Z from negative 2.5 and 1? Well, it's in the middle. It's in between, so you shade in between. Okay? That's why it's very important that you do the pictures, even though it might seem tedious to you. It's better that you do the pictures than to get the problem wrong when you try to memorize something. Ethan?
Was that plus infinity, was that supposed to represent the 1E99?
Yes, the plus infinity is the end of the number line. We don't have a value for the end of the number line because that's not actually a number. So that 1E99 is saying 1 times 10 to the 99th power, and that's 1 followed by 99 zeros, and that's, that's the biggest number that we're very likely to ever encounter. And then negative infinity would just be negative 1E99, which is going the other direction to the end of the number line. But it's the same distance from 0 as what positive 1e to the 99 is. So it's just our best ability to represent to the calculator what infinity is.
So if it's always greater, like Z is greater than like 2.39 or like any other number in that position would be the starting point, and infinity would
Right. Greater than says this is your starting point. Less than says this is your ending point.
and it'll always be infinity unless it's like between another number.
Now, unless you're given 2 numbers, then if you have your ending point, your starting point was negative infinity. If it's pointing to the right, then that's your starting point, and you're going to go to positive infinity because you're going to the right. But if you have both numbers, it's always whatever's in between those 2.
Thank you.
Okay? These are important. That's why I want you to ask questions if you don't understand something. Because if you can get this part down, then the rest of it will be less confusing to you. Okay, this one says we're looking for the probability that we would get a standard score. That's the other name for the Z-score. That you have a standard score that is greater than negative 1.43. First thing we always do, label the curve. Negative 1.43 is between negative 1 and negative 2. When we look at the sign points to the right. That tells you that from that line you are going up. Your greater than symbol is the arrowhead, telling you what direction to go. And since we're going up, that tells us that this negative 1.43 is our lower boundary. Okay? And it tells us that our upper boundary then is going to be positive infinity, which is 1e99. So there's your low and your high. And the area that we're calculating when we do our calculation is this area here. So looking at that, you see that that's a fairly large area. So your probability that you get when you use your normal CDF should be a relatively large probability, which means it's closer to 1 than it is to 0 or 0.5. So same convention. Normal CDF, negative 1.43 to positive infinity with a mean of 0 and a standard deviation of 1, because this is 1. And that's the value of sigma. Okay? So I've entered the command, and it says the area is kind of what I expected it to be. It's a number that's much closer to 1 than it is to either 0 or 1/2. It's very close to 1. So the area, which is the answer to this probability up here, is 0.92364. And I stop after the 5th number because I only need to round to 4 decimal places. And since that number in the 5th place is a 4, then I round down. So my probability is 0.9236, which is equivalent to 92.36%. That's why we go to 4 decimal places. We don't go to a whole decimal. Yes?
Okay, so would you prefer us to like write out the, what you have on the bottom and then round
It
off,
depends on what the question says, and in my stat lab, sometimes it'll ask for one thing and then sometimes it'll ask for another, so you have to pay attention to what the question says. If it says find the probability, it will usually tell you round to 4 decimal places, or it'll say answer as a percentage rounded to 1 decimal place, 2 decimal places. So just pay attention to the rounding directions. Any other questions? Okay, we're going to do one more example, then we're going to move on to doing this process backwards, because the process works forwards and backwards. So this one says the probability that Z is less than some number. So that means we're looking for an area that's going to be to the left of that number. And that number itself is 2.81. And 2.81 is between 2 and 3. And since it's going to the left, that tells you that you're going down to negative infinity, and negative infinity is going to be your beginning point. So that your 2.81 is going to be your ending point. And the area that you're going to shade in is this rather large area. So again, we're expecting an answer that's closer to 1. Okay? It's fairly close to 1. So we're going to start at negative infinity. We're going to go to 2.81. The mean is 0 and the standard deviation is 1. So the area is equal to 0.9975. And then the next decimal place is a 2, which tells us we're just going to drop the 2 and round this off to 0.9975, which is 99.75%. And those are just reminders, since it's been a while since you've done those kind of basic math skills sometimes. So just kind of a reminder of how you convert. Okay? Yes?
So I'm having trouble telling which, if it's going to be the low or the high when there's only a number.
Look at which way the arrow points.
Yeah.
Shade your curve the direction that the arrow points.
I know to do that.
The picture should tell you which is low and which is high. So if you look at this sign says greater than. It points to the right. So you find that number, put it on here, and then point to the right. Now if you're going to the right of that number, where are you starting? If you have to go to the right of the number, where does the shading begin? At that number. Okay, in this other example, this one says less than. Less than means to the left. So our area is going to be the area to the left of that number. So we find that number when we go to the left. Okay, and if your area is to the left of that number, it didn't begin here, it ended there. So you begin on the other side.
So whichever way it's pointing is the side it's going to be on.
Yes.
Okay.
Yes, and that should help you figure out what the lower number and what the higher number is. Okay? Work on these two examples and try to, and those two should get it straight in your head. Okay? Because it doesn't really matter what that number is, if it's positive or negative or whatever. If it's going to the right, you shade above that number, and that means that's your lowest number. If it's going to the left, you shade less than that number, and it's going to the left. And that means that number is your highest end. So these two should, this particular pair of examples should answer your question about that. Okay, the next thing we're going to talk about is something called inverse normal probability. This is going to be where we're going to find z values or x values. Up to this point, we've mostly found z values. Z values or x values that correspond to a given area under the normal curve. In other words, what we're going to be given is we're going to be given this and expected to find the value of that. Or we're going to be given this and expected to find the value of that. So it's the same process, the same idea, except what you're given isn't the low and the high, it isn't the boundaries. It's the probability, it's the area, and you're going to go backwards and find the upper and lower boundary, or actually in most cases what you're going to find is going to be the just one of the upper or lower boundaries, although you can find both upper and lower if you're given an area. You can actually find both. So that's where we're headed with this. We're going to use this when we're given areas and we're trying to find either a z-score, which is your standard normal, or a raw score, which is an x value that's going to be spelled out whatever it is the problem, the value of the random variable. When you're using inverse norm, this is very important, you've got to get this straight in your head. When you're using inverse norm on the calculator, you have to know the area to the left of the z-score. What you may be given is the area to the right. But you should be able to use the area to the right to find the area to the left, because remember, total probability is 1. So if you have been given the area to the right and you need the area to the left to be able to put it in your calculator, what you do is you take the area that's to the right and subtract it from 1, and that'll give you the area to the left. Okay? And I'll draw you an example of that or illustrate that with you as we go through. Just remember, you have to have the area to the left. So we're going to go and do some examples from the notes again. And we're going to begin first, just reminding you that we're going to use this when we are given areas and are trying to find the z or x value. And the difference between finding z and x is just really simple. If it's z, the mean is 0 and the standard deviation is 1. And if it's x, then the problem is going to give you a different mean and standard deviation. Okay? The calculator function you get the same way we started before. It's second vars, and then you're going to choose option number 3, which is inverse norm. And then the thing to remember is the area that we're going to put in with this command has to be the area to the left. Okay? So here's our first example. It says find the indicated z-score, and notice in these cases it's already labeled to solve 0, 1, 2, 3, and -1, -2, -3. So you know that this is your mean, and you know your standard deviation here is 1, and you know that because this is a z-score. And it says find the probability, so this is find the probability that, in this case, something about z is equal to 0.1075. Now the question is, are we saying z is less than a number? Are we saying z is greater than a number? What are we saying about z? Okay, this is the z-score we're looking for right here. We're looking for this edge. Okay? And if that's what we're looking for, and this is the area to the left, then we're finding the probability that z is less than whatever we find, because we're looking for the area to the left. Okay? The command to do that is inverse norm, and this one only has 3 blanks. The first blank is going to be the area to the left. It's the area to the left of the value. These two are the same as what it was before, the mean and the standard deviation. And since this is z-scores, we know the mean is 0 and the standard deviation is 1. So then what we've been given is we've been given the area to the left. And that area to the left is 0.1075. So that's what we're going to put in for our area or our probability. We've been given the probability and asked to find out what z-score, what standard score is associated with that probability being to the left of that z-score. Okay? So whatever we come up with here is going to tell us what this number is here. So we're still using the same menu. Second bar is to get your distributions, but the option is option number 3. Okay, it's option number 3. We enter the area to the left of the number we're trying to find. Then we enter the value of the mean, that's 0. The value of the standard deviation, that's 1. Close the parentheses and hit enter. And it says that that number is negative 1.239, and we always round z-scores off to 2 decimal places. So once I record to the 3rd decimal place, I look at that and say, so that z value is negative 1.24. Okay? Does it make sense that that number would be negative?
Yeah.
Why?
Because
Yeah, the picture shows you that that boundary value, the edge of that dark part, that's less than 0. It's on the negative side. So we should be getting a negative z-score. If this area had been bigger, like over here, then our z-score should have come out to be positive, because we would have been looking at a bigger area, and it would have been to the right of 0. So, use your clues about what you know from just plain old arithmetic. Okay? So, if I have any questions before we do another example. Okay, let's try another one. Okay, now this again, it's going to be, what we're answering is this kind of a question, the probability that z is more than or less than something. But we don't know yet which way we're going, so we're going to have to look at the picture to figure out what we're doing. This one actually is giving us the probability that z, whatever this is, that the probability of it being more than that number, because this area is going to the right, is 5.82%. So notice they were sneaky. They put in a percent. They didn't put in the decimal. So you've got to change that. So the area to the right of z is 0.0582. But if you look at the fact that the area is to the right, that tells you z is greater than, because you're going to the right. So whatever z number it is that we're finding here, that number is going to answer this question. Okay? That's what we're actually finding, is the value of that number. But now think about what your command asks you. The command says inverse norm and we know the mean and standard deviation are always 1. But this has to be the area to the left. So that is z-score. Is that what we have?
No.
What do we need to get the area? How do we get the area to the left from what we do have?
We subtract 1 out of what we have.
Okay, we subtract what we have from 1. Now you can actually do this 2 different ways. You can first subtract it from 1 using your calculator. And so that area that we're going to use, which is the area to the left, which is the area over here, that area is actually .9418. Okay? It's 1 minus the .0582. And that gives us .9418. Now when I do this problem and I come up with the z-score, should my answer be positive or should it be negative?
Positive.
Because where is z located?
Between 1 and 2.
Right, it's between 1 and 2, and that's a positive number because 1 and 2 are positive, okay? It's to the right of 0. That's another way to answer that question. So we're going to go second, bars, choose option 3. We're going to put in 0.9814. I'm sorry, 9418. I'm being dyslexic today. I get into these periods when I'll do this for a while. I don't write letters backwards, I only write numbers backwards. So inverse norm, 0.9418, mean is 0, standard deviation is 1. And it says, indeed, as we thought it would, that it's going to be between 1 and 2, and it is positive, and it is 1.57 if you round it off to 2 decimal places. So this z-score is equal to positive 1.57, makes this 1.57. Okay? Now, that took 2 steps. You can eliminate one of those steps as long as you understand what I just did. So before I tell you you can eliminate the second step, does anybody have a question about why we had to do this step about subtracting from 1? Okay, the reason we had to do the subtraction from 1 is because when we do inverse norm, the first thing it asks us for is what is the area to the left of whatever it is you're trying to find. I didn't have the area to the left. I had the area to the right. Okay? And because I had the area to the right, my brain wandered back to chapter 4 and said, oh, the sum of all the probabilities is 1. And if I have the probability to the right of that number, the probability to the left of that number is based on the number of complements. Remember that rule? That if you have the probability of A, you can find the probability of A not happening by subtracting the probability of A from 1. So that's the reason that we did what we did here. That let us actually use our calculator command then. Okay? The other way we could have done this is we could have skipped that subtraction step as long as you understood why you had to do it. You can skip that subtraction step and you can do this. Go ahead and plug in 1 minus the area to the right, which is 0.0582, then your comma and your mean, and then your comma and your standard deviation, and your calculator, before it actually calculates that z for you, it will first subtract 1 minus the 0.0582, the area to the right, and get the area to the left for you without you having to do that separate step. And notice you got the exact same answer. So either one of those ways of using the command is perfectly fine. One of them saves you a few calculator strokes. The other one requires an extra step. Okay? So you can do it either way. Now the next one we're going to do is going to be an example of what in the world am I going to do if they don't give me the area to the left or the right, either one. What if they give me the area between 2 numbers? And I'm supposed to find the area between both of them. I'm supposed to find both of those numbers. How am I going to do that? Okay, now it's going to take me a few minutes to explain to you how to do this. And I'm going to show you a way that's longer so that you understand why it's working. Then I'll give you a little tip that'll let you not have to do the entire long way. But what I'm looking at here is I'm looking at an area that is centered over the mean, which for these z-scores is mu, and it's 0. And if you'll notice, one of these z-scores is going to be negative. and one of those z-scores is going to be positive because it's centered over the mean of 0, so left of 0 is going to be negative, right of 0 is going to be positive. When you've got a situation like this, this says this is the area between the two. What I need to know is what is the area to the left of that one, and what is the area to the left of this one. Okay? The thing to realize is that this is the chunk in the middle. The total area that is not shaded, the total area that is not shaded is 1 minus 0.7814. So that's a total area of 0.2186. Okay? That's the total of the white area here and the white area here. Now, since this is in the middle and that curve is symmetric, remember, the mean divides it right down the middle, that means that half of that 0.2186 is over here. And it also means that half of that area is on this end. Now, does anybody have any questions about how you know that's true? Does that make sense?
So
Yes.
in problems like this, will it always be centered?
It'll always be centered. They're not going to give you one that's
Okay.
off-center because you really, if you're given something that's off-centered, you really can't tell. There's really not a way to use this easily and figure out the answer. Okay? So if they give you an area that is in the middle, you could assume that it is centered. And for that reason, then, the area in those two tails is half of 1 minus the area you're given. Okay? Now, half of 0.2186 is 0.1093. I'll move the calculator for you in a second. Okay? So the area up here is always going to be the same as the area down here. Now, if I want to find this z-score, knowing this doesn't do me a bit of good unless I subtract it from 1. So that's the command I'm going to use to find that positive z-score. And it gives me a positive answer, which makes sense. And it makes even more sense when you look at where Z is, because that positive answer is 1.23. That's your upper boundary, okay? And then I'll use a similar process to do the other end, but I won't have to subtract from 1, because when I'm going to the other end, what I need to know is I need to know this value of Z, and this is, in fact, the area to the left already. I don't need to do any subtracting. So there's your lower boundary. Does it surprise you that it's the same absolute value as the upper boundary was? No, it shouldn't. Okay, it shouldn't, because remember we said the area was centered. So whatever the value on the right is, the other end, the other value should just simply be that same number, but it should be negative because the curve is identical on both halves. So did we actually need to do both steps of that problem? No. So here's my next question. Which one took the most work?
The right side.
The right side. Because in order to figure out the right side, I first had to figure out that I had to subtract the area I had from 1. Then I had to divide it by 2 to get the area to the right, which was not even something I particularly wanted to know. And then subtract that from 1 again to find out the upper number. Then had a really easy thing to do, finding the lower number, because once I had subtracted 1 minus 0.7814 and then divided that answer by 2, I was ready to find this answer right then. No problem. And once I found that one, all I had to do was drop the negative sign and give the other answer. So you really only had to do that one time. You didn't really need to do both steps. So what I could have just as easily done was I could have simply looked at that picture and said, okay, I have the area between 1 minus the area between divided by 2 is 0.1093. And then once I had that answer, I got the z-score on the left. And then I automatically said, okay, and the z-score on the right is going to be that same number, but it's going to be positive. Because that's always what's going to happen. If you do it twice, all you're going to do is prove that that's what's going to happen. So you can save yourself work by not doing both steps. Just do the first step and then you know the answer to the second step. Okay? Now, if you need to, go back and watch this example again, because that one's important. It'll save you a lot of time and a lot of work. Because we're going to be doing actually something in Chapter 7 that has a lot to do with understanding how this worked. Okay? Let's take about a 10-minute break, because y'all have been sitting there long enough very patiently, and I'm sure by this time somebody needs to get a drink of water or go to the bathroom or just flat out get up and get the blood moving. So let's take a break until about 10 till, and then we'll finish up. Okay, so we will get started back, and example 4 says to find the z-score such that 38% of the area lies to the left of the z-score. Now the thing to remember here is basically they're just leaving it up to you to write the probability statement. So what this sentence says, and it's probably easier to draw a picture first, since this says it's a z-score, then that means that the center of this curve is at 0, and here's 1, 2, 3, -1, -2, -3, and it says the area lies to the left of the z-score and 38% of the area. Okay. 50% of the area is to the left of 0. Okay? 38% is less than 50%. That means that it's going to be on this side, because it says to the left of the z-score. Okay? So 38%, that should be quite a bit. And in fact, we know, because of the empirical rule, we know that 68% is between -1 and +1, or 0.34, or 34% is just right that far. We know that. That's from the empirical rule. So this z-score is somewhere. If that's 0.34, this is only 0.16. That z-score is going to be somewhere between here and here. Okay? That's going to be the approximate location. And all we can do is just pick someplace. And say that we think this is about 38%. Now, we're not experts at this. We're just going to, we may come out with an answer that's not exactly where we drew that line. But it should be somewhere fairly, at least it should be between these two numbers. Okay? It should be between those two. So that area that we're given, which is this area right here, that's the area to the left. Okay? That's the area to the left. Now, if it's, I don't know that it's exactly -1/2. It might be more like -0.2. I don't know. I just know it's somewhere between 0 and -1. Because of knowing about 34% of the curve is there, 16% is there, and so I need more than 16%, so I'm taking some out of the 34% to make it up. Okay? This is inverse norm, just like the others have been, because I've been given an area, and the area that I was given is the area to the left. And And because it's a z-score, I know the mean is 0 and the standard deviation is 1. So that's how I know that that's the right command to use. And it says that score is negative 0.34, or excuse me, negative 0.3054. And I know that because it's a z-score, that I'm going to round it off to 2 decimal places. So my z-score is negative 0.31. Okay? Now, is my market exactly negative 0.31? No, I didn't know what I was looking for. I just knew it was between those two numbers. But it is that negative 0.31 is between negative 1 and 0. So I know that's a reasonable answer. Okay? So I've answered the question. And now the only thing I have left to do is say, does the answer make sense? And looking at my picture, it does seem to make sense. Now, if I really want to check it and make sure that I did it correctly, you can actually, since this one I know is not nearly as straightforward as the ones where you're given the picture. Drawing your own picture is a little tougher. Okay? But what you can do is, once you've got that picture, you can say, well, if I do this, could I get this answer back? Would I be able to verify that? And you can on your calculator. If you got the answer negative 0.31, and that's your z-score, you can verify by going back and doing the problem, doing normal CDF, and saying if my z-score is negative 0.31, and I know the area to the left, which I guess is probably where I should have started. I'm looking for the area to the left. That goes from negative 1, E99 for infinity, up to negative 0.31 with a mean of 0 and a standard deviation of 1. It should come back and tell me something close to the answer that or the probability I was given to start with. So it should be close to, maybe not exactly 0.38, but it should be close to that. So I hit enter. And that's close to it, okay? Now why is it close to it and not exactly 0.38? Why is it not exactly what I thought it was supposed to be? Look at my z-score that I actually got. Look at what I used. I used a rounded answer, so it's going to give me back an area that's close, not perfect, because I rounded the answer. Now, if on the other hand, I had taken that number right there, that z-score, and I had gone and done this, and use second and the negative sign, that ANS says that's the last answer that you saw. That's the number you have stored in your brain. That's what you think answer is. The calculator thinks answer is negative 0.305480791, and about 6 more decimal places it can't show you. So if I take the whole answer and tell it the mean is 0 and the standard deviation is 1, what did I? Oh, sorry. Yeah, that won't work. I forgot to put in the negative infinity. Sorry. Because I have to go from negative infinity up to that answer, which is a z-score. Now what did I do? Oh, because I changed the answer. Hang on. That's the hazard of using answers. It thinks what it thinks answer is changes every time you do something. So negative infinity. It thinks answer is that negative 0.3054, 0 and 1. And now it comes back and it's almost perfect. The reason it's almost perfect, and if you were rounding it to, 38%, well, yeah, that's 38%, okay? The reason it's not exact is because the calculator is doing a numerical approximation, and notice that it is off, but it's off out there in the, let's see, thousands, 10,000s, 100,000s, millions, 10 millions, 100, it's off in the 100 millionths place. So that's not a big deal. That's a very, very small rounding error on the part of the calculator. Okay? You really shouldn't worry too much about checking your answers, because as long as you've drawn your picture should verify that your answer is what you thought it should be. Okay? So we've got two more examples. The first one says find the z-score such that 15% of the area so that's 0.015 is to the right of the z-score. So if I'm going to put 15%, it's going to be to the right of the z-score. That means it's going to be on this end because it's to the right. And I need to figure out what about 15% is. And I remember, I know that between here and here is about 0.34. That's half of that 68%. Okay? So this whole thing is about 16%. If that's about 16%, I need just a little bit less than 16%. So this would be about 15%. And you can put that as 2 decimal places, but you'll just have to add, or 2 extra decimal places, but you'll just have to add zeros. 0.15 will work just fine. Okay? But that's the area to the right. When I'm trying to do my curve and use my calculator, can I use the area to the right? Can I use it directly?
You have to subtract it.
That's right. You have to subtract it from 1. So in this case, I know my area to the left, which is what I'm going to have to use for my command, is going to be 1 minus 0.15. Okay? And that's actually going to be 0.85. But I can let the calculator figure that out for me, just like I did before. I don't have to do it as a separate thing. I just happen to know that that's what that was. So my command then to find this z-score is going to be inverse norm. The area to the left is 1 minus 0.15, and your clue to that was because it said this area is to the right. You need the area to the left. The area to the left is always 1 minus the area to the right. Your mean is 0, your standard deviation is 1. And it says that z-score is 1.036, which we'll round off to 1.04. And that answer, if you look at the picture, does make sense because it should be a little more than 1. It is between 1 and 2. And that number is between 1 and 2, and it's a little more than 1. Okay? So when you're trying to actually locate those areas, you might want to go back to that first page of your notes where I showed you the percentages for the curve and explain the empirical rule, because it marks off different little chunks of the curve, and it helps you figure out where the z-score you're looking for might be, to know what those percentages are. Really, the ones you need to know the most are the ones that are the 0.34 on either side of the mean within 1 standard deviation, which means that then there's 16% if there's 16% here if there's 38% there, or 34% there. Okay? Last example. Find the z-score such that 28% of the area which you have to change to a decimal, lies between two z-scores. Okay, between. Remember when we were doing the example, I told you to go back and look at that and make sure you understood why you could do just one step, that area has to be centered. That 28% has to be in the middle. Okay? So from knowing a little bit about the curve, this is what I know. I know this is the mean. I know the standard deviation is 1, and the empirical rule tells me that 68% total is between those two. But half of that 68%, which is 34%, is here, and half of it's here. Okay? Now, if I want to center that 28%, I need to put half of it on this side and half of it on this side. So half of 28% is 14%. That tells me when I center my 28%, 14% needs to go on this side, and 14% needs to go on the other side. So that's 14%, but that's also 14%. And added together, this total area is 28%. There's my 28% area that they told me to put between. Okay? So I assumed it was in the center. You have to, or you can't do the problem. And that means I have a negative z-score, and I have a positive z-score. And if you remember that other problem we talked about, I really only need to find the negative one. Because the positive one's going to have the same absolute value, it just means I'm going to drop the negative sign. So thinking about my areas, if there's 28% here, 1 minus my 28% is 72%. Okay? You need your calculator, you can use your calculator to do the arithmetic. So that's 72%. That's the total of these unshaded areas, but I only need half of it. Because I need this part of it. So that area to the left is going to be 0.36. I could have also figured that out by knowing that this was 14% and everything to the left of the mean was 50%. So 50% minus 14% is also 0.36. So, as long as you understand the symmetry of the curve, you can figure out what the area to the left is using lots of different methods. But the area to the left then is 0.36. That means to find that z-score, I use that command. And it tells me that that z-score is negative 0.358, which I'm going to call z is equal to negative 0.36. Okay? And then because of symmetry, because the curve is symmetrical, that also tells me that the other z-score is 0.36 because it's on the positive side and it's the same distance away. Questions? Now the examples I did is one example of each of the 3 kinds of ways it can ask you the question. Given the area to the left, given the area to the right, given the area that's in between 2 numbers. Okay? Everything's going to fit one of those templates. What you should do now for your homework is not only work on the My Math Lab homework, part 1. There's actually, I think, 2 parts to chapter 6 or maybe 3. You should be able to do the first part of chapter 6 now, no problem. But you should also go into chapter 6 assignment 1. Okay? Chapter 6 assignment 1 is this worksheet. And it's asking you first to find probabilities, which is the areas, that's normal CDF. And I'll left you plenty of room that those of you that like to use showed-in a stylus with a tablet can do that, or you can print it out, put it on paper, take pictures, load it up. I will remind you one more time that if you happen to be in the library doing this, you can also do your homework on paper, take it upstairs to the 3rd floor and just drop those papers in a scanner and scan it to a file that you can put on a flash drive and load it up from there. It's a PDF file. It converts it to a PDF file. So there's 10 problems doing that. And then there's another 8 problems practicing what we just did this last part of the lesson. Okay? I'm going to go ahead and post the answers to those tonight. It's only going to be the answers. I'm not going to tell you how to get it. But I am going to post the answers to all 18 of those tonight. And then you should be able to get those finished by Thursday night. And if you don't, I'll push the Dropbox date out, or the Shelby date out till about Friday to give you time to work on those some more. But I am going to close it after the due date, so watch the due date when you go in and do it. Make sure you get it in on time. And I will go ahead and post the answers so that you'll know if you're right or not. That way, if you're not getting the right answer, that's the time to go back up there to the top of that assignment and post a question. Say, Ms. Flynn, I'm getting this. You said the answer's supposed to be this for this problem. What am I doing wrong? Okay, and that way I can help you. Matthew, you had a question?
Oh, I was going to ask whether my stat lab this week, but then I remembered to like the difficult test.
Yeah, all the homework and quizzes are due in my stat lab. The homework is due, absolutely due midnight the night before the test, but it does have a due date that's a couple of days before that. Because really, in my stat lab, you should be doing your quizzes the last couple of days before the test. You shouldn't be waiting until then to do the homework. You'll go ahead and get your homework done, then you'll have plenty of time to practice the quizzes. And remember, you can take the quizzes in my